This video will describe the business case behind GridCAE. Computational fluid dynamics is currently the fastest growing segment in computer-aided engineering simulation. The UK market in 2007 was estimated to be €10 million and 150 to 200 million euros worldwide. The market can be characterised with customers having two distinctly different drivers. Early adopters with high budgets who are moving into more complex physics with improved accuracy and business impact, and the followers who have just started out with adoption of CFD. The latter typically have engineers with limited skills in CFD and only 1 to 2 CPU licenses for CFD. This is often insufficient to capture the science they are attempting to simulate. Both market groups are linked by a latent need for access to scalable, cost-effective CFD. CFD simulation calls for varying hardware and software resources. The resource requirement is dependent upon simulation complexity, computer model size, and the optimization required. For small and medium enterprises, this inevitably leads to a resource trap. An organisation may suffer from having too few resources available to carry out a meaningful and accurate simulation. In order to overcome resource shortfalls, the alternative is significant investment in latent computing hardware and software, which may remain underutilised or dormant for significant parts of the year. A value network based upon grid computing resources provides CPU cycles when they are needed. It reduces risk by removing the need to make significant hardware and software investments. In March 2005, ICON purchased a new high-performance computer at a direct cost of £46,000. This resource was required for large computational simulations. The indirect cost to ICON included personnel time spent on system administration and application performance optimization for the machine. In addition, the machine has been unavailable due to hardware faults during several periods. The cost and impact of these faults on the ICON business are not easy to calculate accurately, but are not insignificant. With IT support personnel and managers' time all expended in the fault resolution process, a grid computing resource offers ICON the opportunity to shift that overhead to a third party. On-demand CFD services are already available from 1 or 2 commercial CFD vendors. Some of these initiatives were started 6 to 7 years ago, and the dynamic of the market has not changed considerably to indicate widespread take-up of these facilities. Furthermore, one small CFD vendor that occupies a small percentage of the CFD market has already investigated grid-based services. However, without large uptake from industrial customers or respected technology integrators, the uptake would so far seem to be limited to innovators and early adopters. The scalability of a comparable grid-enabled CFD solution should, however, offer additional benefits that would be more attractive to the market, as its price point should be lower. A number of business-related considerations are continually being addressed. These include data security implications for confidential models, attractive pricing models for ICON as a grid end user, attractive licensing models for application software running on the grid, and reduced IT asset value on company balance sheet. There are some legal issues as well. These include the necessity for proprietary software vendors to approve licensing models for the grid, where licenses may not be by user or machine, but per time slot, flat rate, etc. Legal agreements are also needed to reflect that CFD computations will be performed on a third-party cluster. Benefits of the grid can only be obtained after some initial outlay and investment of time and resources. Additional time required when considering legal confidentiality agreements. Also, it requires time to select a suitable grid service provider and port bespoke application software to grid computer. The availability of the grid means that the company can maintain smaller systems and exploit the grid when larger simulations are necessary. The benefits include reduced energy bills due to less IT equipment and air conditioning, reduced rented office space required to house IT equipment, reduced IT systems administration, reduced management time required to evaluate hardware decisions, no need to buy expensive equipment for infrequent computations. A grid environment can be considered more environmentally friendly as it results in reduction in waste such as unused hardware resources and needless air conditioning. This offers end users like Icon the chance to market themselves as a green business as a part of corporate social responsibility. The customer value from a grid-based solution can be summarised as follows. Increased speed by producing solutions in hours instead of weeks. Increased flexibility by paying out of specific project budgets. Reduced cost due to shorter overall programs, lower development costs and more effective labour deployment. Improved quality such as by producing enhanced solutions from higher resolution models. The grid enables Icon to retain and extend both its own and its customers' competitiveness. Thank you for listening. For further information, please visit the Gridipedia website.